This presentation, we're going to first define the problem and then look at some of the root causes of it and then hopefully get into the solution. The problem is what I've seen in my career, which is backed up by this slide and this study that was done by PM Solutions. We know that we have a lot of organizations that have PMOs, upwards of 80%. We know that there was a time several years ago where a lot of them closed or failed, up to 50% closed between 2006 and 2010. And in the research that was done, what really stuck out to me, which I've also seen with my clients, is most PMOs, actually, if you look at the mature PMOs, only 37% of them, they cited their biggest problem as being able to have a resource management process that optimizes resources and allocating resources, and specifically how to deal with resource contention issues. If you look at all PMOs, that number is actually 24%. So 3 out of 4 PMOs basically cite that they do not have a process in place for optimizing resources across projects and do not have a process in place for managing resource conflicts. I think what we want to do is look at what some of this, what causes some of these factors or causes this statistic to be so high. Due to 3 seemingly beneficial policies, some widely accepted PM practices, and prevailing organizational structures, most businesses that continually share resources across projects experience enough multitasking or task switching to cut their productivity in half. We'll actually look at a case study in this presentation as well. So this presentation, what we're going to do is look at the root causes of project portfolio underperformance and outline the steps needed to increase the speed of benefit recognition through improved productivity of your portfolio components. The first place to start is we have to get down some terminology to make sure we understand how we interpret some key definitions. The first one is, what is a task? A task is all the work that a subject matter expert performs, whether it be an engineer, a developer, a business analyst, an operations person who's working on a project. It's all this work that subject matter expert performs to create any output that is required by another worker or somebody waiting external to the worker's business to complete the project or complete the task or complete the deliverable. So what we have is the tasks are work that is done by subject matter experts that are handed off to other knowledge experts or subject matter experts. The start and the end of a task are punctuated by these interactions, these transfers between these subject matter experts. What is multitasking? Multitasking is when a knowledge worker is required to perform 2 or more tasks simultaneously or to switch from one task to another several times before that worker can finish any of the tasks. So we see this commonly. You're working on a task, some other issue comes to your plate or gets put on your desk. You've got to divert your attention to that task and finish it, and then come back to your project task that you're working on. Multitasking almost always involves tasks from different projects. However, multitasking does not occur in response to some emergent problem when a knowledge worker is required to stop working on a current task, but is then directed to resolve a problem with focus and without further interruptions. So if a worker is pulled off a given task and works the new emergent task to completion, we don't define that as multitasking. But what we do define it is when they have to start a task, they can't complete it, and then they have to come back to it because of some other competing priority. So let's look at how multitasking hurts. Here we have 2 projects, Project 1 and Project 2. We have worker A, B, and C. You can see here how worker A simply hands off, completes a task in 4 days, hands it off to worker B for project 1, who then hands it off to worker C for project 1. You can see these handoffs occurring between day 4 and around day 8. When multitasking occurs, what we see is, for the same 2 projects, we see worker A working between 2 tasks between project 1 and project 2 and having to divert their attention, thus delaying the handoffs between worker A and worker B. Subsequently, this works downstream. Worker B continues to multitask across project 1 and project 2, delaying the handoff to worker C. So what has essentially happened here is that work or additional capacity that could have been used to finish project 1 or P1 and attain those corresponding revenues earlier for the business or operation, that capacity was used up because project P2 was strategically added early into the work in process, causing this task switching to occur. So a more simple example would be something like this. There's a little bit of humor in this slide as well. But if you were going to run a race to get to the pot at the end of the rainbow, the pot of gold there, and you were running a relay race to hand off the baton to your next worker, representing this knowledge worker, handing off a piece of work to the next person that is required to complete that project, it would be silly to run the race this way. It would make more sense to run the race and give the baton directly to the first person and then complete the next task and give the baton to the person working the other project. So the impact of multitasking is pretty devastating when we measure it, and we have measured this in the organizations that we've worked with. When multitasking occurred, this is what consistently happens. This is a slide. This is a case study from a software company, Confluence, that we worked on. And you can see on the left-hand scale here, we'll go through this slowly. On the left-hand side, you have the actual scope of the project represented in the staff days of effort. So it might be 100 days of effort, 200 days of effort, 300 days of effort, and so on. On the horizontal axis, we have duration to complete the projects in the number of business days. These blue dots here represent the performance of a portfolio of projects representing both the size, the scope of the project, as well as the duration. You can see that the mean or average of the scope was pretty similar, 87, or was 92 days in this case, and the standard deviation was 145. When we remove multitasking through a systematic process, which we'll get to in terms of what that process looks like, the results look like this. The white dots are different projects, but of similar mean, 87, and similar standard deviation, 140, and you can see most of these white dots has moved to the left, basically meaning that duration was significantly shorter. So in other words, the organization was able to get much more productivity